Hello everyone. Today we'll work on leetcode problem 1420, build array, where you can find the maximum exactly k comparisons. So we're actually given some code. This is a very new idea of presenting a problem. So we are giving this code, and it is to find the maximum value, and by compare each number with some fixed pre-defined maximum value variable. And then if we find some number in this array is greater than this maximum value, then we will add the search cost by 1. Okay, so this number needs us to return the number of ways to build this array under the mentioned conditions. This condition includes these two. So the first, we need k integers. And the second is we are given some number m, and each number in this array should be less or equal to m and larger or equal to 1. And third one is after apply this mentioned algorithm, which is this algorithm, and the value of this search cost is equal to k, which means we can only we can have only k elements, which is increasing sequence, right? So this if can only be true for k times. And here are three examples, and we won't go through them one by one, but you know the idea. And we'll directly go to the solution part. So in order to solve this problem, let's actually take a look at the data range. So the n is less than 50, okay? It's a pretty small number, but large enough that we cannot use exhaustive search. M is less than 100, and k is on the same order of n. So I think the hardest part of this problem, and I think if you have done some write some problems before, then you might have a feeling that this should be solved by dynamic programming, okay? Especially when you see some data range like this, and this is also to compute the number of ways, okay? So you will have some feeling that this problem should be solved by dynamic programming. Then the hardest part for dynamic programming is to find out the status representation. How to represent this, how to define this state is the hardest part. So here we say that we can define the state this way. So we define it as FICJ, where I represent, let's write it here. I represent the first I element, okay? So which means 0 to I minus 1. Then we have C. C is defined as the cost. The cost is just the search cost. And J means the maximum value is J. Okay, so that FICJ means in elements from 0 to I minus 1 with search cost equals C and the max value J, how many ways to build the array from 0 until I minus 1. Okay, so this is the state. Then what we need to do is to find out the state transfer. Okay, so how to transfer the state. So notice that there are two ways we can reach ICJ here. And the first way is in the at I minus 1, we already have max value equals j. Okay, and of course, the second situation is at I minus 1, we have max value less than j. Okay, these are two very natural conditions we can consider. And for the first condition, actually the state transition is Ficj should be equal to Fi minus 1 Cj, because we already have the maximum value, so the cost doesn't increase. And then we times j. It's the number of ways. Okay, this is plus equal. So j means we can choose choose 1 until j at current position. So total j choices. So that we multiply j here. Okay, and for the second condition, we say Ficj is actually with all the possible transition from I minus 1 and with some cost C prime Cp and we say it's Q here. Okay, and this means at I minus 1 we have the maximum value less than j, and we come to j and added some value that is equal to j. So this indicates, so we need to choose j at I position. Okay, we need to choose j here. So this means this Cp is actually C minus 1, because after we choose j, we added one more search cost. So this is increased from C minus 1 to C. Then for this Q, it's actually a sum for all Q in range 1 until j minus 1, right? Okay, so in this way, we have all the state definition and the state transfer functions. So I think we can write the code now. We will first define the dp function, because the range of n is just 50. So we define 55 here. So we have some buffer. And the c, the range of c is also on the order of n. So we have also 55 here. And m's range is 100, so we say 105, and we initiate the value size of f. And we actually notice if for example, the maximum value is for the array is m. So if we need m less than k, we just return 0. Yeah, this is impossible, right? You have only m different numbers, and you want an increasing sequence of k, and which is larger than m, then it's impossible. Then we can start the dp process, and we will initiate all the values for the first position, I that's equal to m, so plus I. We initiate 1 I equals to 1. So this means for the first element, and the maximum element we can get is 1. And how many ways to have an increasing element? So it is 1, right? With a search cost 1, and we need the maximum value is I. Then the only way is to put the number I here, so it's just 1. Okay, then for int I equals 2, we already considered I equals 1 here, and I equals 0 means nothing, we do not care. I equals 2, I less equals n plus plus I. This is I. Then for c equals 1, c less equals to m plus plus c, and for j equals 1, j less equal to m plus plus j. So similar to this condition, if c is less than j, we just continue. It means we never be able to do it because the c is greater than j, because we have only j different number, but we want a cost greater than this number. It's impossible. Okay, then we can write the state transition function here. So the first part is this equation. The second part is actually this equation. So we expressively write the sum. It is for int q equals 1, q less than j plus plus q. Then it should be ficj plus equal to this value, right? I think that's all for the DP part. Then we will sum up all the values because it asks us to get all the number of ways to build an array with cost equal to k, right? So for I equals 1, I less equal to m plus plus I, res plus equal to fi is n, then need a cost equal to k, then the maximum value can loop over all these choices. Some of them might be 0, but we can just ignore the difference and just add all of them. Let's try. Yeah, I think it worked. And I think before we submit, we need to handle this part. So we need to consider all the very large numbers. So we define m equals 1e9 plus 7. Then I think this part should be ficj plus m. Okay, and this part is also ficj plus this modular by m, and this part the same. So res and modular by m. Let's test. Okay, let's submit and see if it works. Let's see. Well, I think something wrong here, right? The index are out of bound. Let's see. M, N, and M. Oh, I think for C, for the cost, the maximum cost should be N, right? It's not M. Let's try again. I think this is caused by this part. right? Because we are doing some multiple here. So it's very likely that this number is very huge. So we change it to long and do the multiplication. Then we add a modular m here. Let's see. Yeah, I think this works. Let's submit. Okay, it passed. So this is a pretty hard problem, and I think the most difficult part is to find out how to represent this state. And after you define this state, it's the first I element with search cost C, and the maximum value is J. Then the number of ways to make this array is Fij. Then you need to consider two situations for state transfer. The first situation is at I minus 1 position, we already have the maximum value equal to J. Then for the current position, we can choose whatever J we want as long as this J is less or equal to J, right? So we have J choices from 1 to J. So this state transition is this function. And another situation is at the previous position, we have the maximum value less than J. This means we need to choose J as the current position. So this means we have only one choice for J. However, to have a maximum value less than J, there are a lot of ways, so that we need to sum over all the possible ways. All the possible ways is for this Q value in the range 1 to J minus 1. They are all possible uh, ways to get a maximum value less than J. Okay, and I think you need to handle very large numbers, but this is not very hard. Okay, I think that's all for this problem, and thank you, and see you next time.